A warm wishes to you all. I'm Shweta. I am here with my teammates Karthik Har, Pallavi C, and Ullas SM under the guidance of Professor Yashashwini ma'am for the project proposal Brain Tumor Detection Using Deep Learning. Hi, on behalf of my team, welcome you all. Now, let's have a overview on these contents. Now, let's begin with the introduction.
A brain tumor is considered as one of the aggressive diseases among the children and adults. Brain tumors accounts for 85% to 90% of all primary central nervous system CNS. In every year, around 11,700 people are diagnosed with brain tumors. The 5 years survival rate for the people with a cancerous brain or CNS brain is approximately 34% for men and 36% for women. Brain tumors are classified as benign tumors, malignant tumors, pituitary tumors, etc. Proper treatment planning and accurate diagnostics should be implemented to improve the life of the patients. The best technique to detect the brain tumors is MRI, magnetic resonance image. The huge amount of data images are generated through the scans. These images are examined by the radiologist. A manual examination can be error prone due to level of complexities involving the brain tumors and their properties. Applications of automated classification techniques using ML machine learning and AI artificial intelligence as consistently show higher accuracy than the manual classification.
Motivation. A brain tumor is a deadly disease that medical science has ever seen over the years. A brain tumor diagnosis has become a vital one in medical field because they are caused by abnormal and uncontrolled growing of cell inside the brain. A brain tumor detection is done using MRI and analyzing it. A brain MRI images is mainly used to detect the tumor and tumor progress modeling process. This information is mainly used for tumor detection and treatment process. The deep learning is very powerful strategy for the detection of brain tumor from MRI. A much higher accuracy can be achieved by gaining images taken directly from the MRI scanner. Purpose of the project is to identify the tumor in the brain by processing the image and extracting the region of interest based on the data segmentation. Problem statement. In the medical field, tumor is detected by doctor by referring the MRI images, which is very time consuming. Therefore, to overcome this problem, an alternative way is to design the system that will automatically identify the presence of tumor in MRI images using deep learning techniques and also provide faster and accurate solutions.
In reality, existing system is what look like this. In existing system, tumors to be identified by specialists and it takes more time to analyze the data so that there will be no accurate results. In existing system, find out tumor from MRI images, but it is somewhat time consuming and difficult task. Sometimes performed manually by medical experts, large amount of time was spent by radiologists and doctors for identification of tumor and segmenting it from other brain tissues. However, exact labeling brain tumor is a time-consuming task and considerable variation is observed between doctors. Having this existing system, disadvantages are time-consuming, manual work, there is no accuracy due to human error or equipment error. Before going to proposed system, let's have a look how existing systems was handled before. In 2014, skull masking was done and classification techniques based on support vector machines SVM was used. In 2016, K-mean segmentation with preprocessing of image was used with use of object labeling algorithm. In 2018, texture features were extracted from segmented binary image using GLCM. GLCM means gray level co-occurrence matrix. Then feed-forward neural network FFNN was used for the classification of MRI in 2018. In 2020, we are with a new idea for the classification of CNN. We are using it as CNN is become very popular nowadays. We are using CNN for classification, and for segmentation, we are using mask or CNN. So the advantages of proposed systems are less time consumption. The main objective of the software was to reduce the time consumed for the process of detecting tumor via MRI scan. The software reduces the time of the user and doctors drastically by using the technique called deep learning technology. The other one is more accuracy. As the base of this program is a deep learning, as you all know that a large number of data is collected from various hospitals or the MRI scan of brain. A huge library is generated over servers and it's regularly updated. This can guarantee that data reading and perfect representation of the spots or the whites which are reflected on the image to the image which is being uploaded by a user, thus giving an accurate result. And the last one is user-friendly interface. Many other applications can have a complex interface, but this application as a graphical represented user interface can reduce the time of the operator and a new user who wants to use this software. Now, the objectives. Pallavi?
The main objective of our project is to analyze the presence of brain tumor using deep learning techniques from captured MR images. To perform segmentation process on MRI images to separate the brain tumor from normal brain tissues. To evaluate the performance of various deep learning models, we are building an user-friendly web-based application.
Now, as to keep it simple, let me explain how project is going to work in a two parts. The one is brain tumor classification, the other one is brain tumor segmentation. Methodology is divided into two parts. In that brain tumor classification, let me explain. We train the CNN model to detect whether there is a presence of tumor or not. Let's take a look how exactly it is going to work. First of all, collecting the data sets and pre-processing the data sets. In pre-processing, we are using two things. There are many things to do, but we are mainly intended on two things. The one is contouring of image. In contouring of image is used to remove the edges and noises. The other one is the data augmentation. We are running with less amount of data sets. In order to improve the data sets, we are doing the data augmentation, taking the data sets copy or copy of the data set image and rotating it and flipping it. Now, you may think that why image cropping is needed or data augmentation. The purpose of image cropping is the MRIs contain a black background around the central image of the brain. This black background provides no useful information, right, about the tumor and would be waste if fed to neural networks. Hence, cropping the image around the main contour would be useful. But augmentation, the amount of data gathered was very low and could cause the models to underfit. Hence, we would use a brilliant technique of data augmentation to increase the amount of data. This techniques relies on rotations, flips, change in exposure, etc. To create similar images using these techniques, we can increase the size of data by a higher factor. Next, we train the CNN model. If the user gives an input to a CNN model, if there is a tumor, it will identify that whether it is a benign tumor or malignant. If there is no tumor, it will exit and display a pop-up message saying that there is no tumor. This is what a brain tumor classification. Now let's look on brain tumor segmentation.
So before that, we are building two types of neural networks to build build a model. So first one is convolution neural network. Convolution neural network is gaining popularity nowadays. Convolution neural network is one of the variants of neural network used heavily in the field of computer vision. It derives its name from the type of hidden layers it consists of. The hidden layers of a CNN typically consist of convolution layers, pooling layers, fully connected layers, and normalization layers. CNN are very good at features extraction. Thus, they can learn features of all the classes. The different types of layers in CNN help in extracting the important features from the image. Hence, convolution neural networks makes it great for the recognition. Apart from this, we are also trying to make a model using transfer learning. So, transfer learning is basically a machine learning model technique where a model trained on one task is repurposed, or we can say we are reused on a second related task. There are many pre-trained models available which are really good at classifying images. We can use these pre-trained models to classify MRI image using transfer learning. These pre-trained models are available in Keras API. Hence, using augment data, we try to train various transfer learning models like ResNet 50, VGG 16, VGG 90, and Inception V3. And we will try to we will compare the two models. We see which gives us the better accuracy. Once the classification is done on the brain tumor, if there is a if there is a presence of tumor in it, we perform the segmentation on the MRI image. So, yeah, in our project, we are making use of mask RCNN to build an actual detector which will point out the location to the tumor on the scan. So, mask RCNN is a deep neural network aimed to solve instant segmentation problem in machine learning or computer vision. So, MRCNN always gives a consistent results. The segmented tumor are always clear and identifiable. Also, RCNN creates a boundary around every object that is present in the given image. That's it.
Let's look on the technology stack. Operating system, Windows 7 or above. Framework, Flask. Language, Python. IDE, Jupyter Notebook.
Okay, Shweta, stop it now. Just Karthik or yourself, just summarize the entire thing.
Yeah, ma'am.
Hmm.
In our project, we are going to divide it into two parts. The one is brain tumor classification. The other one is brain tumor segmentation. In classification, we collect the data sets and we pre-process it. We train the CNN model to detect whether there is a tumor or not. As when the user gives an input to the model, it has to detect if there is no tumor, it will exit. If there is a tumor, it will detect that benign or malignant. After knowing that whether there is a tumor present or not, in this step we will get to know there is a tumor or not. The next step is to know that where the tumor is present, the location of the tumor has to know. In order to know that, we are using an brain tumor segmentation. Instant segmentation has been used here. Previously they were using GLCM. Now we are with a technique called mask RCNN. We'll use this technique and identify where the tumor is present. The location of the tumor is what I mean.
Okay, Shweta,
Yeah,
Victor sir
ma'am.
is having some questions. Just answer those questions. Hemant sir, Victor sir, Suhas sir, Anand sir, you can ask questions now.
From my side, I have some basic questions. The very first question is, once again, we are seeing tumor detection using deep learning for many years. Maybe, to my knowledge, from almost past 3-4 years, we are seeing that. Can I
Sir,
know what's the new thing you have incorporated as
sir, you
part
are
of
not
this
audible, sir.
solution, which you can claim as a recent influence? Hope you got my comment. Hello.
Sir,
The question is, we are seeing this project for many years,
yeah.
detecting brain tumors, blood cancer, using neural networks, deep learning, CNN. So I'm more interested in knowing how your project is different compared
Yes,
to the
sir.
other ones.
Yeah, okay.
Or to put it in other terms, what are the new things you have incorporated to improvise on the performance of your application?
Yes,
Or
sir.
your time?
Previously, they were using for segmentation the technique called GLCM, Gray Level Co-occurrence Matrix. But now we are using the mask RCNN.
Now, how it will help us improvise the accuracy of the
Sir,
using
accuracy
mask?
can be improved by training the model into by deploying the
Yes,
model.
previous mechanisms that were available was pinpointing the location of the tumor and also the stage of the tumor. That is one more thing I did not know. You should
Ah,
also indicate the stage in which the tumor cell is, or the tumor is occurring at that point of time. Stage 1, stage 2. I think different stages are there. Actually, we have seen these type of projects done 2, 3 years back, which was also giving indicators of the current stage in which the tumor cell, I mean, or the so
Okay,
I did not
sir.
notice that
Okay,
in your
using mass
explanation.
carcinoid also we can. Okay, sir. If that's so the case, we can also take the size of that and we can detect whether it's a
The
which
stage.
stage it is in.
Ah,
Okay, sir. That using that size itself we can do. But the main thing, what actually there was from 2013 also, there are majorly changes as being done, sir. Like previously, they used to making use of SVM and KNN, K nearest neighbors. It was until 2016. Once the neural networks concept came in 2016 afterwards, they made use of ANN also, multi-layer perceptrons also. They try to classify at that time also. See, so we are changing the classification methodology rather than just segmenting. What you are saying
this
is
changing
it's
is
on the
not
part of the
no.
segmentation
The
part.
thing is, this changing is not
Okay,
the
sir.
answer.
That is
Why you are
also
changing?
yes, sir. Because it improves accuracy. We know artificial neural networks used to it gives the CNN will give more accuracy than the previous one. The previous methodologies like ANN, artificial neural networks and multi-layer perceptron. So CNN was also used in the paper we saw. So we are trying to implement the same with transfer learning, training through the like ResNet models or VGG90 and VGG16 models. We are also want to train to the transfer learning models also to evaluate the performance and compare it to the models that previously used.
Still, did not explain my answer, but still, okay, it's okay, no problem. Since it is the starting stage of your review, I hope that after detailed literature survey, that will be milestone too. So you will give us more clarity regarding all these aspects. And also, you need to be more specific about the segmentation technique you are using, the pre-processing techniques at this point of time itself. Because in segmentation itself, we have many ways of doing the segmentation. So, which segmentation approach you are adopting, which pre-processing, what pre-processing you are doing. So, if you give more specifics of
So, sir, shall I
you
give
are
a
doing,
small introduction about mask RC, the technology behind mask
I think
RCNN?
no, that is it a segmentation technique that mask RCA?
Yes, sir. It's a segmentation. It's an instant segmentation technique. We know instant segmentation detection technique as two problems itself. It is used for object detection and semantic segmentation. It involves both the detection technology. The object detection, in the sense, once it see the object, it just put a bounding box around it. Whereas in object detection, in semantic segmentation, it goes to the pixel level and tries to put the outline to it. Whereas
I
in
think
instant
Victor,
segmentation, it tries to
Okay, wait,
Victor
guys,
sir, I
wait.
think you can take over regarding
Wait,
that
let me come in.
segmentation and stuff.
So, I think most of you, like, you are so particularly defending ideas. You don't want to take inputs. So I will just say a few things and I will leave it up to you guys, okay? So first thing is
okay,
this.
sir.
I listened to Shweta. She was telling that the existing models are time-consuming, manual. Shweta, where did you learn all those things from?
What, sir?
Which journal did you refer that the existing system? No, don't worry, don't argue, just listen. The first one, you said they are manual, they are time consuming, and the accuracy is less because it's done manually. Please, that is misinformation, okay? So rule that out and please do a literature survey. That is first point. Second point, even looking at this image which you have presented here, this was just a kind of a dorsal view of the slice of the brain. Now, there are various modalities of capturing brain images apart from MRI. You have not looked into that. I'm going to give you some hints. If you feel like you study it, if you don't want, you leave it. Now we have what we call PET and PET CT, positron emission tomography, and we even have cerebral angiogram, and we have lumbar puncture or spinal tap, and we have myelogram, whatever. There are several techniques that are there which you have not looked into. And next thing, you telling me that you are classifying before segmentation. You said you classify, and you're already talking as if the project is done. You are defending your ideas based on maybe 1 or 2 papers which you have read. Please understand that first thing you should look at technologies which are existing. I will refer you to one institute, it's called FAR Institute, F-A-R-R, F-A-R-R is in Scotland, okay? They have the state-of-the-art things to do, both brain tumor segmentation, COVID detection, everything. Please don't just tell based on few papers. Another one, I want you to look at this website also, Q.ai. Identify technologies that are existing and try to take one small thing in which you can improvise. First thing, telling mask RNN is used for segmentation is blatant lie. Okay, I have worked on this for a couple of months now. Okay, and even for me, I find this difficult to understand most of the things here. Now, in CNN, there is nothing like feature selection. It's done automatically, right? So how do you improve misclassification? How do you identify region of interest? Now, if you say you want to segment this, how is thresholding different from region margin? How is it different from watershed transform? So you can look at some certain things. And even looking at this image was smoothened. And you said something about one thing again. You said you are not interested in the black area. Please understand that the brain consists of so many things. What you are referring as black area is called the gray matter. We have the white matter and we have the CSF. The main components of the brain is gray matter, white matter, and CSF. And if you want to quantify these things, you have to do what we call region-based segmentation, which you look at voxels and not pixels. Okay, so at this stage, please don't confuse us by telling so many things and you are presenting it as if, oh my goodness. So this project is existing somewhere and you are telling all the technologies that you already know. Please do a thorough research on this and please look for renowned papers from renowned authors. Don't just base your references from few papers, okay? And please look into this because even when you are trying to understand the nature of tumor, how the brain cells are degenerated, you need to look at CSFs, okay? The cerebral whatever fluid. And if you see, if much fluid is there, then there is a degeneration in that area. So how do you identify that? So you should sit down with ma'am and then look at something, okay? Take one tiny strand of the research project. Don't take everything because seriously, you're gonna mess up the whole thing, okay? That is my idea, but please guys, first thing, possibly send the papers which you have referred. I will vet it, it will take me only a few minutes and I'll tell you whether those papers meet the criteria. Okay, don't base your arguments based on some papers which doesn't meet a required criteria, okay? That's it for now. If you want to take it, if you don't want, that's fine. Thank you.
Thank you, sir.
Shweta,
Ma'am.
Anand sir is asking one question.
Yeah, ma'am.
At what stage of cancer you are working on?
Ma'am, presently we are trying to segment it, trying to improve the segmentation accuracy and classification accuracy, ma'am.
He is asking about the stages. That is whether you are looking on or what.
No, sir, no, ma'am, we are not thinking about the what stage it is.
Okay. Okay, then you can wind up the session. Thank you, Hemant sir. Thank you, Suha sir, Anand sir, Victor sir. Thank you, one and all.
Thank you, sir. Thank you, one and all.